So today we're going to start moving into section 10.3, our final section, which is going to put the angle ideas from 10.2 together with the trig ideas from section 10.1. In 10.1 we talked about sine, cosine, and tangent, and of course we had that whole SOHCAHTOA thing. Sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. But we saw that kind of only works when we have a right triangle and we can pick out all those sides. What I'd like to do now is show you how we can extend this to deal with any sort of angle. I am going to take an angle with the initial ray over there and the terminal ray somewhere in quadrant 1. I'm going to say over here that my angle is theta, although we're going to see in a moment, even though this is a quadrant 1 angle that I'm dealing with, these definitions I'm about to give you will apply in any quadrants. I'm going to put a point over here, and I'm going to kind of draw a little right triangle like that. That point is the point x, comma, y. This little right triangle that I drew out, what's the base of that triangle? Well, if the coordinates of this point are x, comma, y, the base of that triangle has got to be x. The height of that triangle then has got to be y, the y coordinate of that point. As for the hypotenuse, well, first of all, I'm going to call it r, as in the radius of some sort of circle that I'm spinning around here. However, we can calculate that r by using our Pythagorean theorem. We can say r squared equals x squared plus y squared. But I really wanted r, not just r squared. I can say r equals the square root of x squared plus y squared. So now, if I want to find the sine of my angle, I can use my definition from the first section, although in a moment we're going to see how we can extend this, of the opposite of theta over the hypotenuse. Well, opposite of theta is y. The hypotenuse is r. The sine of theta is y over r. The cosine of theta is the adjacent over the hypotenuse. Adjacent is x, the hypotenuse is r, so x over r. The tangent of theta is the opposite over the adjacent, so in this case it's y over x. This is actually a bigger deal than it might seem. These new definitions of sine, cosine, and tangent no longer specifically refer to a right triangle. They refer to some point that our terminal ray of an angle is going to pass through. And if I just know the x and y coordinates of that point and can calculate my r, my radius, I can find my sine, cosine, and tangent. Let me show you what we can do with this. In letter A down here, first of all, in all these examples, we're asked to find the 3 trig ratios for the angle and standard position that passes through the given point. I'm going to go and graph this thing out. I want to deal with the point 5, negative 12, 5, negative 12, maybe about here. I'm going to say that point is 5, negative 12. And I have a terminal ray of an angle passing through there. My angle is the angle that starts over here, goes around like that, and ends up there. Something bigger than 270 degrees. Suppose it also could be the negative angle that starts here and ends up down there. We don't really know, and it's not going to matter as far as our work's concerned. I want to find the sine, the cosine, and the tangent of this angle. Well, I have an x, I have a y, I just need to know an r, the distance from the origin to this point. Well, I don't even really care so much about that. I have a formula that's going to get me my r. R is going to equal the square root of my x-coordinate 5 plus my y-coordinate negative 12. We'll square both of those. My r looks like the square root of 25 plus 144. Square root of 169. My r is 13. I now have all the information I need to be able to find my sine, my cosine, and my tangent. The sine of that really big angle is the opposite. No, it's not. It's sure opposite over hypotenuse, but that's not helpful when I can't draw a triangle with an angle like that inside. But I can use my new definition that my sine is my y coordinate over the r. I can say that my sine is negative 12 over 13. I want the cosine of my angle. Well, that's my x over my r. X is 5, r is 13, so 5 over 13. Finally, I want the tangent of my angle, so that means my y over my x, negative 12 over 5. That's how that works. Even though I wasn't able to draw a right triangle with this really big angle inside there, I can now find sines, cosines, and tangents using these new definitions and moving away from the whole opposite, adjacent, and hypotenuse thing. Next, I want to deal with the angle whose terminal ray goes through negative 1, comma negative 6. Negative 1, negative 6, maybe about here. So dealing with an angle that looks like that. I've got my x, I've got my y. My r, according to my formula, is the square root of negative 1 in parentheses squared plus negative 6 in parentheses squared. R is going to look like the square root of 1 plus 36, or the square root of 37. Honestly, I guess I didn't even really need the picture. We're going to see moving forward, the picture will be very important. But for these, I've got my x, I've got my y, I've got a formula for r. I guess we don't even have to bother with that. If I want the sine of theta, it's my y over my r, so negative 6 over the square root of 37. The cosine of theta is my x over my r, so negative 1 over root 37. And the tangent of theta is my y over my x, so negative 6 over negative 1. Now, all of these, I have a little bit of work that I need to do with. I need to rationalize my denominator here, so multiply by root 37 over root 37 to get negative 6 root 37 over 37. Multiply here by root 37 over root 37 to get negative root 37 over 37. And over here, we'll just simplify. Negative 6 over negative 1 simplifies to positive 6. As always, if I'm going a little bit too fast, pause the video before we go on. I don't really feel like drawing any more pictures of these. I think I'm just going to go use my formulas and be good. My x-coordinate is negative 3. My y-coordinate is root 7. R equals the square root of negative 3 squared plus root 7 squared. So that's going to be the square root of 9 plus 7, or the square root of 16. Oh, that's actually kind of nice. My r is 4. Okay, so the sine of theta is my y over my r, root 7 over 4. Cosine of theta is my x over my r, negative 3 over 4. The tangent of theta is my y over my x, root 7 over negative 3. You go do letter D. Pause the video, take a moment, see what you can do with letter D. getting the sine to be 5 root 61 over 61, the cosine to be 6 root 61 over 61, and 5 over 6 for the tangent. There's one other type of problem we're going to look at today that involves extending our trig functions. I'm going to tell you one trig ratio, you're going to find the others. We did a little bit of this on our first day, but now it's going to become a little bit different now that we are dealing with angles not necessarily within a right triangle. Vocab reference angle, do I want to define this now? Yeah, I might as well define this now. I'm going to say that a reference angle is the acute angle between the terminal ray and the x-axis. This will make sense in a moment. It is the acute angle between the terminal ray and the x-axis. The reference angle is the acute angle between the terminal ray and the x-axis. We will see why this is important, and I'll show you exactly what it means. Actually, no, why don't I show you what it means right now? Let's say we have an angle with the terminal ray over here. Here's my angle theta. Well, the reference angle is between the terminal ray and the x-axis, so it's this little angle, this little acute angle inside there. Let's see what we're going to do with this. Given that the sine of an angle is 4/5, and theta is between pi over 2 and pi, I want to find the cosine of theta and the tangent of theta. Okay, I realize this looks a little bit like what we did on the first day, but it's a little bit different because of this inequality over here. To start a problem like this, I'm going to draw a ray in the appropriate quadrant for theta. Draw a ray in the appropriate quadrant for theta. Here's what I mean by that. I know that theta is an angle between pi over 2, or 90 degrees, and pi, or 180 degrees. Here's where that unit circle stuff really comes in. Here's pi over 2. Here's pi. I have no clue where exactly the angle is, but I know its terminal ray is going to be in quadrant 2. So theta is that obtuse angle over there. Step number 2. I'm going to create a triangle with the x-axis, and I'm going to sort of highlight my reference angle. Actually, not just a triangle. Why don't I say create a right triangle with the x-axis and show the reference angle. Okay, well, here's my right triangle over there. I know my angle theta is that one, but the reference angle, this little acute angle over here. What I'm now going to do is use SOHCAHTOA, opposite adjacent hypotenuse stuff, to label the sides of my triangle based on the reference angle, and I'm going to find the missing side. I'm going to use SOHCAHTOA and the reference angle to label the sides of the triangle. I'm also going to find the missing side. I'm going to use SOHCAHTOA and the reference angle to label the sides of the triangle. Here's what I meant by that. The side of my angle is 4/5. If I look at this as the angle that I'm kind of focusing on now, the opposite is going to be 4, and the hypotenuse is going to be 5. So I'm going to label this side as 4, and this side as 5. Oh, and I definitely know what the other side has to be. I don't even have to use Pythagorean theorem here. I know that that side has to be 3. But I'm not done. I want to find the cosine of theta and the tangent of theta, but it's not quite as easy as just starting to do adjacent over hypotenuse and opposite over adjacent. Here's where most people usually get stuck, by just sort of skipping this step. I'm then going to find the x, y coordinates of the point that's on the ray, paying very close attention to the signs, the positives and the negatives. I'm going to find the x, y coordinates of the point on the ray, paying close attention to the signs. Paying close attention to the signs. I'm going to find the coordinates of that point on the ray, paying close attention to the signs. Here's what I mean by this. I need coordinates of this point. My x-coordinate, well, that's the horizontal stuff, but I'm not going to say it's 3. Because I'm moving left to get there, I have to say that it's -3. As for the y-coordinate, well, I'm going up to get there. +4 is good. I've got everything I need. My x is -3, my y is 4, and my r is 5. By the way, that radius is always something positive because it's a radius. It has to be a positive distance. Finishing this off, step 5. I'm going to find the remaining trig values not using SOHCAHTOA, but using the x, y, and r definitions. I'm going to find the remaining trig values using x, y, and r. The cosine should be x over r, which in this case is -3 over 5. If you tried using SOHCAHTOA, you would get +3 over 5, which would be wrong. The signs, the positives, negatives, is really like half of what this is all about. The tangent of theta is y over x, which is 4 over -3, or just -4/3. I need to show you a couple more of these, because there's a lot that goes into these problems. I need to use unit circle ideas to know where to draw that terminal ray. I'm then going to make a right triangle. I'm going to use SOHCAHTOA to fill in 2 sides and Pythagorean theorem or Pythagorean triples to find the remaining side. I'm then going to turn that point into something with coordinates, focusing on should each coordinate be positive or negative based on how we move to get there. And then I'm going to use my x, y, and r definitions to find my particular trig expressions. Let's see a couple more. I think I have 3 more examples. No, 2 more examples to show you. Next one, given that the cosine of theta is -6/7, and theta is, well, I guess this time I use degrees, theta is between 180 and 270, find the sine of theta and the tangent of theta. So I'm going to start by drawing my angle. Because of this, I know that here's 180, here's 270, so my terminal ray, somewhere in quadrant 3. And this is the angle that I care about. That's my theta. I want to make a right triangle with the x-axis. Right angle over there. And I'm going to go highlight my reference angle, which in this case is that. Using the reference angle, I'm going to fill in my sides. Cosine is adjacent over hypotenuse. Ignore the negative over there. We'll deal with that later. But my adjacent will be 6, and my hypotenuse will be 7. I can find the other side by using Pythagorean theorem. I can say x squared plus 6 squared equals 7 squared. We'll call this x for right now. X squared plus 36 equals 49. I'll subtract. And we're going to get x squared equals 13. X equals, remember, I don't care about the plus or minus here because they're distances and distances have to be positive. We're going to say square root of 13. I then want to get coordinates for this point. My x coordinate, I'm moving left 6. X coordinate is going to be negative 6. Y coordinate, well, I'm moving down root 13, so my y coordinate is going to be negative square root of 13. I've got my x, I've got my y, I've got my r, and I have everything I need now to find the sine of theta and the tangent of theta. The sine is y over r. Y coordinate is negative root 13. R is 7. The r was a square root. I'd have to rationalize the denominator. But it's not. Then I need to do the cosine of theta. No, I don't. I already know what the cosine of theta is. Just for fun, I'll repeat it. It's that negative 6 over 7 that I already got from there. The tangent of theta is my y over my x. So negative root 13 over negative 6. I can simplify. I don't want negatives on the top and the bottom, so I'll say root 13 over 6. And we're good. One last one, and then you'll try a couple in the homework. I'm telling you that the cosine of theta is 1/6, and theta is between 3 pi over 2 and 2 pi. 3 pi over 2, that's 270 degrees over here. 2 pi is over here, so my angle is something kind of like that. I'm going to go and make a right triangle with the positive x-axis. And I'll go highlight that reference angle over there. I'm going to use some SOHCAHTOA to know that my adjacent is 1 and my hypotenuse is 6. I'll say that's x, and I'll go use Pythagorean theorem. 1 squared plus x squared equals 6 squared. 1 plus x squared equals 36. Minus 1 minus 1. X squared equals 35. So x is going to equal square root of 35. I'm going to go put some coordinates on this point. I moved right 1 and down root 35. My coordinates will become 1 comma negative root 35. X, y, and again my r is 6. And I think I should be good to go now. I need to find the tangent of theta, which is my y over r. That's negative root 35 over 6. Sorry, I think I said tangent. I meant sine. My sine of theta equals y over r, negative root 35 over 6. I don't need cosine because it was given. The tangent is my y over my x. That is negative root 35 over 1, or negative root 35. I guess I didn't have any examples where we had to rationalize the denominator, but you could see that in the homework. Last thing we'll do in this section, which we're going to save for the next video, is start applying all those good angles around the unit circle to this stuff. And we'll be able to find the sine of 30 degrees and the cosine of 5 pi over 4, radians, or the tangent of 11 pi over 6. We'll save that for our next video, which will be our last video.